And hey, welcome viewers to the Daily Space Weather. Just bringing you the most detailed imagery of the sun and most comprehensive space weather you'll find in the known universe here at the Smash News Network, least busted name in news. And thanks for tuning in and stargazing with us. We're starting out looking at the sun in ionized carbon. And a quick reminder here. You see all those bright white colored regions around sunspots like down here and over here and down here and up here. Those are all areas that are high in carbon. Now, if you think that carbon is just showing up to play tiddlywinks with those sunspots, think again. That carbon is being nuclear fused right there on the surface of the sun before your very eyes. And when you see a flaring event, you'll see more carbon appearing. That is the sun building the carbon nuclei right there on the surface. And the evidence of it is X-ray output. Anyway, let's continue on here since there's a massive filament fest going on. I mean, you've got the Brian Keating, you've got the Nikki Haley, and then you've got this huge prominence down here. Also massive filaments in the northern hemisphere. So likelihood of coronal mass ejections remains at nearly 100%, just like it was yesterday. Let's go around the horn as we've got at least one new sunspot having recently formed up there in the northeast. So there's some splentacular imagery of that. Let's move to the northwest. How about the southwest? Great view of those ginormous filaments there. And they've traversed most of their way around the solar disk, at least the Earth-facing portion of it. This one here is the Nikki Haley, and this one here is the Brian Keating, Dr. Brian Keating, or Professor Brian Keating, if you prefer. And how about a close-up of that massive prominence, which has since split in two. So that is an unsustainable prominence there. And when the magnetic fields suddenly shift, you can expect to see parts of that, or maybe even most of that, blasting out through the greater solar system. At the moment, it's just relocated part of it closer to the south heliographic pole. We'll show you some of the latest imagery of that from the GOES 16 SUVI a little bit later in the video. First, take a moment to press like and subscribe if you enjoy the content. Tell your friends and foes about us. We decided to make the channel quite a while ago as we noticed that there were holes in the realm of cosmology. So back in the mid-90s, I realized that heliophysics is lacking. And so our understanding of the rest of cosmology lies on heliophysics. I'm sure there are plenty of astronomers out there who refuse to look at things like distant galaxies until we have a better comprehension of what makes the sun tick. So that's why we're writing a paper about what makes the sun tick. It's kind of important, and when it passes peer review, it'll just be one of the most important science papers in hundreds of years. So if you'd like to support those missions, please do visit the links below the video, become a member of the SMASH team, etc. As we strive to MACSA, MACSA, which stands for Make Astronomy and Cosmology Science Again. So, of course, we're not specifically calling anybody out on cosmology and astronomy at the moment. However, there are certainly some issues, some inconsistencies, and you might notice lots of data refuting the sort of widely accepted hypotheses about what makes stars and galaxies behave the way they do. And so part of the purpose of the channel here is to make astronomy and cosmology science again. So it's pretty serious. There's a lot of non-science out there. And, you know, the color scheme here is symbolic, like all of our merch. You've got the red and blue and the purple, right? The purple represents the B field. Yeah, the field that goes through the magnet. That's your purple. The blue is North Pole magnetism, and the red is South Pole magnetism. Visit the links below the video to find the merch shop. You'll find our Redbubble shop in order of best selling if you click that link below the video in the description. And if you're viewing on BitChute, you might want to go subscribe on YouTube as you're missing most of the content. When will you stop believing NASA's lies and realize that the Earth is croissant-shaped? And let's get back to solar data here. Here's SDO intensitygram, and that is a lot of sunspots, as many as 14 named sunspot groups, and thanks for leaving a comment, Mike. Doing delightfully. How are you? So we've got the major flare players are this sunspot up here and this sunspot down here. Those are the two most likely, at least on a 24-hour basis, to be producing solar flares, although things have been pretty calm here. And it looks like, we do have another group down here in the south as well. So at least two new named sunspot groups to show up today. Here's your SDO colorized magnetogram. And those are a lot of active regions, folks. And we're still not at solar maximum. We'll tell you why when we look at the coronal hole view. First, let's take a look at Croissant Earth, which appears to have a volcanic uptick on a global scale. So, interestingly enough, lots of volcanoes erupting, including Shiveluch, which is now exploding and producing a 13,000-foot plume of volcanic ash. That's a flight level 130 over the Kamchatka Peninsula from the Shiveluch volcano. Abiko also producing a 9,000-foot ash plume, 9,000-foot ash plume from Sakurajima. Suwanosejima, also a 9,000-foot ash plume. Mount Ibu exploding, flight level 060. It's a 6,000-foot ash plume over Halmahera. Krakatau now back on the list, exploding and producing a 5,000-foot plume of volcanic ash. Please don't pole vault the caldera. It's a flight level 06060. It says 5,000 and 6,000 in my defense. Semeru also exploding, flight level 140. It's a 14,000-foot ash plume over East Java, Indonesia. Dakono producing a 7,000-foot ash plume. And the White Island volcano there, the small island volcano there north of the North Island of New Zealand, showing some temperatures at 240 degrees Celsius. Also, a lot of rain has filled up the crater. So that heavy rainfall has caused the crater lake levels to rise. As a result, some fumaroles are now underwater, leading to geysering and bubbling. So the alert level there at the White Island volcano remains at level 2. One of the deadliest volcanoes in the world, as it killed a few people and injured some more, idiotically going on tour at the White Island volcano a couple of years ago. Tanaga in the Aleutian Islands, as well as Takawanga and Tanaga are both at alert level orange there. So both volcanoes there on the Tanaga Island, volcanic island in the Aleutians, looking like perhaps some eruptive behavior to start out there. Headed down to central Mexico, Popocatépetl exploding, flight level 220, flight level 150 over Guatemala from Fuego. Sangay producing effusive lava flows and some gas and ash plumes over the past week, and intermittent puffs from Sabancaya in Peru are a reminder that it is not done erupting either. And thanks for leaving a comment, Tinman1057. Let's take a look at global seismicity briefly as well. It's been fairly calm here, not a lot of earthquakes. That's your 90-day bar graph. And here's the past day. The largest quake of the past 24 hours was only a 5.4 magnitude, I believe. We'll report those over a 5. So Papua New Guinea had a 5.1 at 1748 Universal Time yesterday afternoon. Quite a low number of volcanoes here over the past, a low number of earthquakes over the past 24 hours. Papua New Guinea had a 5.0. That was early this morning at 0:58 Universal Time. Also, Peru had a 5.0. That was at depth, over 160 kilometers estimated depth, 6 minutes before 5 o'clock this morning at 4:54 Universal Time. So there's the largest quake of the past 24, that 5.4 at Colombia. That was at 9:18 this morning. And there was also at 11 o'clock this morning a 5.0 at Papua New Guinea. And let's get back to space. And this is one of our new favorite wavelengths here. So 211 plus 171 angstroms. It shows great depth to the corona. The 211 angstroms shows not only coronal holes, but also the extended corona. 171 angstroms shows the lower corona. And that is just some great imagery. Don't worry, there's plenty more. Now we've swapped out the 211 angstroms for 131. So this is 171 plus 131. By the way, all three of those wavelengths are all ionized iron, different species of different numbers of electrons in the shells of the iron nuclei. The 10.7 centimeter radial flux has dropped down to 179 solar flux units. And again, we're seeing a support level here right around 180 solar flux units. That's the 1 year graph. Looks like a new high is maybe around the near corner here. So also you're seeing this uptick in the AP index. That's an average of global geomagnetism, by the way. You can see that AP, that's the blue line down there, as that's ramping up. And once again, I would cite the fact that we are not at solar maximum yet, and those out there telling you that we are should just admit that they're incorrect. Anyway, continuing on to a space weather enthusiast dashboard there. No geomagnetic storms or geomagnetic unrest forecasted by NOAA. I would tend to agree. It's pretty clear sailing out there, although there is a coronal hole high-speed stream likely coming in a few days. We'll get to that here. First, the last 4 hours of Earth's magnetic moment from space. It's our Geospace Magnetosphere movie. We cover it daily on the channel. And we've been making these videos for pushing 6 years at this point. Congratulations on realizing the channel exists. Next comes Earth's magnetic moment from the ground. So this is ground magnetic perturbations map. This shows magnetic flux density, or nanotesla. And geomagnetically calm conditions are the current situation. So no major aurora there likely. You do see some magnetic pulses coming out of the equatorial part of the planet there, especially at the beginning. And our global geomagnetism is currently at a KP1. So that's a geomagnetically calm condition there indeed, KP1. The calmest we've had in quite a while, actually. Continuing on to our real-time solar wind data, measured at Lagrangian point 1, the gravitational equilibrium point about 1 million miles toward the sun, in between Earth and sun. Let's see what the ACE and Discover have been measuring lately. It looks like we've got some error suspect for some reason there. Current conditions are shown as 416 kilometers per second for the solar wind velocity. Solar wind density here just below 4 protons per cubic centimeter. And consumer tip, some people think that the solar wind will cause wind at the surface of the Earth. So let's just put out some numbers here for you. At the surface level, the amount of protons per cubic centimeter is something like 4 quadrillion protons per cubic centimeter, as opposed to 4 protons per cubic centimeter. One of the many reasons why space weather does not affect your Earth weather directly. It only affects the upper portion of the stratosphere on its best day. Anyway, here are the GOES magnetometers, and seeing some higher highs and higher lows there in the past 24 hours. Those are the measurements by the GOES 16 and GOES 18 in their geosynchronous near equatorial orbits. And if you're new to the channel, these M's stand for midnight local time. The N's stand for noon local time for the satellite. The red one there is the GOES 16. The blue one is the GOES 18. And let's take a look at the heliospheric current sheet. Since the Earth has recently crossed into a North Pole current sheet, we may see some different effects here as a result of incoming space weather, but they'll be minor. So this imagery here, the top view ecliptic plane field plot, part of the National Sunspot Observatory GONG 2 data. The potential field surface model data is super good at forecasting. And in fact, right over here, you can see there's a very bunched up portion of plasma right there about to rotate in. See lots of plasma hanging out there. That's an indication that there's some activity underneath all that plasma, as something has to suspend it, and that thing is magnetic field. So let's look at our line of sight field plot next. There you have the sun's B field in blue, North Pole in green, south magnetic pole in red. And let's move to coronal holes, since they give us insight into how close to solar maximum we are. So, one of the features you want to see at solar maximum is very little magnetism around the heliographic poles. So it's getting there. It is indeed getting there. But we've still got a ways to go here. So there has been some progression, certainly, in the past couple of months here. Anyway, that's the current situation. Let's bring up the latest image there. And we're going to look at 211 angstroms. So we've got North Pole coronal holes here. Only North Pole coronal holes here in the east portion of the solar disk. So here are the past. That's yesterday plus today's imagery. And this coronal hole right here, we can expect that to become geo-effective in about 5 days, 4 to 5 days at its current location there. And of course, our regular viewers are well aware that coronal holes are the source of high-speed coronal hole wind streams. There are protons blasting out of that coronal hole into the greater solar system. And of course, coronal holes are super important features as they inform us of the solar cycle progression. The solar polar field reversal process becomes evident when we view coronal holes. Of course, you got to know the polarity, so it's nice to have both that and the 211 angstroms wavelength. That's why we show them both. Next, moving to sunspots. Another sort of important feature of solar cycles, perhaps not as important as the magnetic environment, at least the coronal hole environment, we'll say. Of course, sunspots are also magnetic features. And, coronal holes are kind of like low-pressure zones. Low-pressure zones on stars are so extreme that they blast material out into space. A little bit different than Earth's low-pressure zones. Sunspots are kind of like high-pressure zones as they constrain material instead of bulging out material. Anyway, that's the current situation, and that's what we call a lot of sunspots. Again, the most likely sunspots to produce large flares are 3242, 3245, and I think 3250, is it? 3250 is another significant flare player. We'll show you the fields here later in the video. It's not super important, although we've been seeing kind of a low amount of solar flares in the past couple of days. So here are the sunspot images we've collated for you. That's the last 24 hours in SDO continuum plus 171 angstroms. Looks like there is indeed another sunspot rising up here in the northeast. Also, one has formed ahead of that. Don't worry, we'll show you the high-res imagery at the transition between space weather and meteorology. So there's what's going on. Let's subtract the 171 angstroms. There's just the SDO continuum, and again, that is a lot of sunspots, and many of those are larger than the Earth. So at least 3 sunspots there that are the size of the Earth or larger, and several that are a significant percentage of Earth's diameter. New sunspot up here. I think that one's a new one as well. Let me go back here for a minute. 3251 did get a name, so I believe we'll have 2 new named groups up here, 3252, 3252, and 3253, assuming no other ones form in the meantime. Next, let's take a look at energetic particles, and there ain't none. The Gauss proton flux is flatlined. As far as solar flares go, it's been ramping down here. So if we look at the 7-day graph, you can see a significant ramp down following some large M-class flares. And now we're pushing down to the bottom of the C-class background output range. So only C-class intensifications. The X-ray output has been, at least as far as the GOES 18 long, has been constrained to a C-class X-ray output. It looks like it may drop below there, so kind of a low X-ray flux over the past couple of days there. Here's 94 plus 131 angstroms, and the brightening areas there, those will be the most likely places to see large flares. I would say mainly these two groups. I mean, this one's showing a little bit of promise, and also as this group rises up here, that produces some likelihood. So you've got 1, 2, you've got about 4 possibilities for large flares. Those are the most likely spots. I mean, you're just looking at bright spots at this point. And let's move on to a star chart. So the moon has just set here. It's just in the process of setting over Lehigh Valley, Pennsylvania. If you're up before dawn, you might see Mercury and Saturn rising ahead of the sun. If you've got low light pollution, you might be able to see Mercury. Saturn should be real obvious, and if you're viewing the evening sky, you might be able to see Jupiter and Venus. Here's a solar system diagram. Keep in mind it's not to scale. We're going to show you the 1 week forecast. There's where things will be in a week. Not a lot of planets on this side of the solar system. In fact, only one. It's Earth. Next, looking at some CMEs here, and you may hear today some people saying, hey, it's a halo eruption. Those CMEs are earthly directed, and we're here to tell you that they're not. We wish that they were because we want to see more aurora here in Pennsylvania. However, those are not earthly directed. So we're going to show you why we think they're not earthly directed here. That might look like a halo eruption, the kind that is earthly directed, but I don't think so. So that's yesterday's imagery. Here's today's imagery. And let's move to stereo A and the Soho-Lasco C3. So we've paused this here at 1430 for the Soho-Lasco C3. And for you new viewers, the Earth would be behind you from this perspective, about 1 million miles behind you. And from stereo A's perspective, Earth would be off in that direction. Just keep in mind, again, that stereo A is getting very close to Earth. It's only a few degrees off of the Earth now. Not at Lagrange 0.5 anymore. Anyway, once again, we paused this here at 1423 and 1430 because this one might look like a halo eruption. But what's happening is 2 CMEs at the same time, actually. So there's an event on the far side, and there's also an event in the southwestern portion. So you see this CME down here. This is this one. That is not on the Earth side. In fact, none of this is really on the Earth side of the solar disk. Let's just bring that back and play it through. By the way, this is Mercury that you're seeing down here. It's also Mercury on the stereo A, giving you an indication of how close together stereo A and Earth are. So those are the CMEs. And when you look at our 24-hour videos, you'll probably agree with me that these are not earthly directed. So you might hear some people spooked about it today, spooked and scared about it. Even if it was earthly directed, it wouldn't be scary in the slightest. It would be a reason to celebrate, as we want to see more aurora over Lehigh Valley, Pennsylvania. So, looking at this image, one of the great things about this is you'll be able to see filamentary eruptions. So because, we've got 304 angstroms included there, typically when you see an Earth side CME, you'll see some material moving around there. And we're not really seeing that. I think we are seeing some after effects of a flare on the far side of the sun that are reverberating around. As you can see, some areas brightening. Let's move in a little closer here. You see some areas brightening here soon after those CMEs happened. That could be like a reverberation effect, because keep in mind, helioseismology does appear to be a thing. Like, there's a reason why there's a solid body rotation inside the sun there, and it has to do with what it's made out of. Now, we're not going to go into that in this video. This is the daily space weather, so we don't want to get too in-depth or, frankly, too controversial, as these videos are designed to not offend anybody, whether it's Tamitha Skov, Pierre-Marie Robitaille, Eugene Bagashov, Brian Keating, Scott McIntosh, or other people who know what we're talking about when it comes to space weather. So here's the past 24. These are all 24-hour videos as well, by the way, folks. So we don't really see any filaments. There's no limb darkening there. Those events are from the far side. And here's the past 24 and 304 angstroms alone. And let's move to filaments next. So since there's a massive filament fest going on once again, it's a great day to name that filament. This one up here needs a name for sure. And this prominence should probably get a name, even though it is split in two. So if you want to name filaments, don't do it in the YouTube comments. We won't accept it. You've got to name filaments on Twitter. So join us over there. You'll find us all over the internet at Smash-O-Mash. But we want you to follow on Twitter, because there's all kinds of stuff that we share there that we don't talk about at all in YouTube videos. So it's not only a way to promote the channel, it's a way to promote other information. So you're invited, if you're watching this video, even if you're watching it from BitChute, to join us over on Twitter and name that filament. So we're looking for names for, and you could also name this one down here, but certainly this prominence and this huge, very dense filament up here, they both need names. So join us over on Twitter for that, at Smash-O-Mash. Here's some more imagery that we just threw up there. That's 335 plus 1,700 angstroms. And let's take a look at the past couple of hours. That's the past 24 hours at 30 frames per second. And here's the past couple of hours from GOES 16 SUVI. And we've moved the imagery down here a little bit to show you that prominence, since it is in the process of relocating itself. It's becoming a South Pole crown prominence, actually. I mean, up here it's debatable. Down here, that's a legit crown prominence. So this is a feature that you'll see more as we get closer and closer to solar maximum. Crown prominences are, well, you won't see those around solar minimum because there's a huge coronal hole that's just fixated at the heliographic poles at solar minimum. At solar maximum, not so much. Anyway, there's the full disk view. That's the past about 2.5 hours from the GOES 16 SUVI with its fantastic wide field of view. Great at showing CMEs as they happen, prominences, filamentary eruptions, filamentary relocations, etc. And that brings us to our bonus feature segment with satellite charging hazards, which have just dissipated. There were some, and now there are none. The satellite's community dashboard there, no satellite charging hazards. There is your GOES electron flux. We are seeing a decline here in the electron flux. There is the forecast model from NOAA expecting a slight reduction here in the electron flux today. There is the one-year chart to put it in context. We did reach fairly high levels there. And we'll show the layer of the thermosphere where that's measured, the F layer of the ionosphere, shown there by that red F. It's located at about 300 kilometers of altitude. Feel free to pause the video on this frame if you're not familiar with the penetration of electromagnetic radiation into the Earth's atmospheric layers, or thermospheric temperatures and molecular concentrations. So here is our ionogram. This is the raw vibrational frequency in megahertz. And we are seeing some major anomalies here around the South Atlantic anomaly. So right over the South American continent, right about there, is where the South Atlantic anomaly is generally located. I'll use the caveat generally here because we documented it moving around thousands of miles into the South Pacific, up toward the equatorial Pacific, and then back down over the South American continent, which is where it appears to be now. It is, you could say, the most interesting portion of Earth's magnetosphere, as it is a weak spot. And perhaps it gives us insight into internal processes that generate Earth's magnetic dynamo. In any case, there is your ionospheric data. And if you're not familiar with looking at that, we show the anomalygram. So this is the anomaly in megahertz from a 30-day median. Keep in mind this does show 10 times more resolution because it's showing anomaly in megahertz to 1/10 of a megahertz. the raw ionogram imagery only shows integer megahertz. So anyway, that's what's going on for the anomalygram. And these low-frequency anomalies right here are quite odd. So we've got one stretching from the African Rift Zone across the Atlantic Ocean to South America. And we believe that, well, I believe at least, I don't know if SMASH staff agrees, but I believe that low-frequency anomalies actually do give us some insight into things. And I'm not going to say that you're able to forecast earthquakes with this imagery, but there is some emerging science suggesting that perhaps it is a thing. It's part of the reason why we show it on the channel, as there are lots of channels on YouTube that claim to forecast earthquakes, and it's pretty pathetic because I don't believe they forecasted a single earthquake. You can't just go follow all the fault lines around and say an earthquake might occur on all the fault lines. That's not forecasting. That's nonsense. Anyway, here's the latest image. And if you think you're forecasting earthquakes, we want to see a successful forecast. Just one. Just one. Anyway, there's the latest image, 1245 Universal Time ionogram and 1245 Universal Time anomalygram. Another interesting feature is the total electron content, as it gives you insight into what's going on in the inner portion of the outer Van Allen belt, the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. Here is your total electron content forecast. It'll show you the most likely places to see GPS errors, as those free electrons can refract your GPS satellite signal. Things aren't looking particularly anomalously here. However, you should note that there is a low electron anomaly over the Caribbean, over the southern portion of South America, and actually west of South America. There's a small anomaly. You'll see it right about right there, a small low electron anomaly there. So I'll leave my pointer there and let that play through one more time. You'll see a low electron anomaly over the Caribbean, another one over Argentina, southern South America, and then you'll see a third spot there, a low electron content anomaly. And let's take a look at the latest solar intensitygram, also the latest solar magnetogram. So let's take a look at these new groups up here. Little alpha class sunspot group up there. In fact, that one's pretty weird. That looks like it might have a leading South Pole umbra. It's a little unexpected. I suspect that's a North Pole umbra there. I'm not sure. It looks. I suspect that's an alpha class North Pole umbra there. This one down here, that looks alpha class as well. Only one umbra there. It is certainly North Pole. Anyway, here's the full disk rock back. We won't worry too much about the field complexity of those sunspots. Rest assured that this sunspot is still beta gamma delta class, and this group down here is also, oh, that one might only be beta gamma class. No, that's still beta gamma delta class. Anyway, it's time to move to the meteorology segment. In the meantime, if you haven't visited the links below the video, please do. Hit us up on social media. Check out the Hemp Lucid link. Save some cash using the promo code SMASHOMASH on checkout to save some dough on your CBDs, mushroom gummies, body balms, and more. Even CBDs for your pets. Available on Hemp Lucid site. Again, enter the promo code SMASHOMASH to save some dough, or just shop via our link if you prefer that. Thanks to everybody who's picked up items and perhaps improved your health. If you want to support the content, consider becoming a member of the Smash Team at smashomash.com/Smash Team. Join at the gold level if you want to hear our hypothesis about the mechanism underlying the solar sunspot cycles before we even release it to preprint for peer review. Yeah, it's going to be serious. SmashOmash.com is the official homepage of the channel, the Smash News Network, least busted name in news. If you visit the Hemp Lucid link, you'll find the products there. So check them out. Shop, buy, solution, etc. The products are splentacular. And a quick reminder that winter is almost over, folks. Winter is almost over. Only 10 days and 8 hours from the time we stream this video. Let's press refresh. I think I may be incorrect. Yeah, only 10 days and 8 hours and 24 minutes until the March equinox. By the way, we will be streaming live on YouTube at 5:24 p.m. on March 20th, the moment of the equinox. And let's get into our meteorology segment here. We don't want the video to be too lengthy. So this is the jet stream scenario for the eastern world. And this is the surface wind situation. Here is the surface wind scenario for the western world. It's still pretty stormy in the North Atlantic. Here are the jet streams of the Americas. Jet stream divergence happening in the west and the eastern Pacific. And last but not least, the jet streams of the central world. And let's don't forget the surface winds. So that's what's going on. How about clouds and fog over the Americas? There's the 3.9 nanometer infrared radiation map. As we zoom in closer and closer to the lower 48. Next, our weather.gov map. If your location is lit, click your location. Click your location. We've got some blizzard warnings in Montana and North Dakota. Dag. Also some additional snow coming to Pennsylvania. So it's been a weak series of winters for the Boston to D.C. corridor. However, the Northern Hemisphere has seen 7 consecutive winters of record snowfall. Yeah, those in California probably agree, as it's gotten to the point where it's quite deadly, actually, in large portions of California where people are not used to dealing with snow at all, getting snowed into their cars. And some guy spent 7 days in his car, snowed in. He's 81 years old, a retired Air Force veteran, but he survived, fortunately. Anyway, let's do some forecasts here. Here is your temperature anomaly forecast for the next 72 hours. Based on the GFS model, keep in mind it's showing anomaly in degrees Celsius. Also, pressure and precipitation. Here's pressure and precipitation based on the same model. As precipitation continues to inundate California. It's like the world capital of moisture. And where do you see the snow totals? That's 72-hour GFS pressure and precipitation. And here's the total accumulated snow depth forecast. Same model, GFS 72-hour model, and some heavy snows coming to the southern Rockies despite all the hot air coming out of Colorado constantly. A lot of bloviating blowhards spouting nonsense in Colorado are not going to prevent an additional 15 inches of snow falling. And look at the totals there in California. Places like Tahoe expecting another 4 feet of snow, as if they haven't had enough. It just continues piling on and on and on. So we've actually brought up the windy.com snow depth map. One of the great features of windy.com is you can actually look at snow depth. And check it out there. South of South Tahoe, 60.9 inches on the ground. North of South Tahoe, 63 inches on the ground. That is indeed quite a bit of the white stuff. Now let's switch to new snow. There's the next 3 days, and you can see massive snow forecasts for especially California. That's the Euro model. Here's the GFS model that we showed earlier. The Euro model showing even higher snow totals there in a more concentrated zone, a little more spread out on the GFS model. Again, Euro model, GFS model. Windy.com, check it out. Next, our lightning mapper. And what's going on with lightning? There was certainly some lightning across Texas, Louisiana, Mississippi, Alabama, and Georgia. And I think we may have some current thunderstorms. There we go. So some lightning striking there around Macon, Georgia, and Columbus and Montgomery, Alabama. The area south of Atlanta. Okay, Columbus. There's thunder rolling in. Anyway, that's your real-time lightning map from lightningmaps.org. Here's your U.S. Doppler radar. It's showing vertical motion in the air column. Those ground-based systems are available for your convenience at radar.weather.gov. Looks like some snow moving into the mid-Atlantic states as we speak. Here is your shortwave radiation map showing clouds and fog. Very cloudy there west of the Rockies. Last but not least, your water vapor map. You can see lots of Pacific moisture moving in there, just crossing the Rockies as we speak. Here's your recap to close out the video. U.S. Doppler radar facts. Satellite-based infrared radiation facts. It's 3.9 nanometers. And satellite-based water vapor facts. We put a lot of them into the channel, and we hope you're dense. Yeah, dense, because dense brains have the tendency to be smarter ones. Anyway, thanks for tuning in. Congratulations once again on realizing the channel exists. We'll see you soon at the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Please do not forget to visit the links here and here and so on.